Hi, today we'll be learning in detail about decision-making instructions. Decision-making comes under control instructions. In decision-making, the program conditions the computer to check if the given data is satisfying the applied condition or not. In general, many a times we want a set of instructions to be executed in one situation and an entirely different set of instructions to be executed in another situation. This kind of situation is dealt in C program using a decision control instruction. As mentioned earlier, a decision control instruction can be implemented in C using the if statement, the if-else statement, and the condition operators. Now let us learn each of these and their variations in turn. The if statement. Like most languages, C uses the keyword if to implement the decision control instruction. The general form of if statement looks like this. If this condition is true, execute this statement. The keyword if tells the compiler that what follows is a decision control instruction. The condition following the keyword if is always enclosed within a pair of parentheses. If the condition, whatever it is true, then the statement is executed. If the condition is not true, then the statement is not executed. Instead, the program skips past it. But how do we express the condition itself in C, and how do we evaluate its truth or falsity? As a general rule, we express a condition using C's relational operators. The relational operators allow us to compare two values to see whether they are equal to each other, unequal, or whether one is greater than the other. Here is how they look and how they are evaluated in C. Is x equal to y? Is x not equal to y? Is x less than y? Is x greater than y? Is x less than equal to y? And is x greater than equal to y? The relational operators should be familiar to you except for the equality operator, which is a double is equal to, and the inequality operator, which is exclamatory mark with an equal to sign. Note that a single equal to is used for assigning a value to a particular variable, whereas a double equal to is used for comparison between two quantities. Here is a simple program which demonstrates the use of if and the relational operators. On execution of this program, if you type a number less than or equal to 10, you get a message on the screen through printf. If you type some other number, the program does not do anything. The following flowchart would help you to understand the flow of control in the program. The program starts, which takes in a number less than 10. The input from the user is taken as a number num. If the number num is less than 10, then it prints what an obedient server you are. If not, it ends the program. To make you comfortable with the decision control instruction, one more example has been given below. Study it carefully before reading further. To help you understand it easily, the program is accompanied by an appropriate flowchart. While purchasing certain items, a discount of 10% is offered if the quantity purchased is more than 1000. If quantity or price per item are input through the keyboard, write a program to calculate the total expenses. So here is the code given. Let's have some sample interactions with the program. Let the quantity be 1200 and the rate be 15.5. So the total expense will be 16,740. In the first run of the program, taking these sample interactions, the condition evaluates to true as 1200 is greater than 1000. Therefore, the variable dis, which means discount, which was earlier set to 0, now gets a new value 10. Using this new value, total expenses are calculated and printed. Now let's take another value. Let the quantity be 200 and the rate be 15.5 itself. So the total expense will be 3100. In the second run, the condition evaluates to false as 200 being the quantity isn't greater than 1000. Thus, discount which is earlier set to 0 remains 0 and hence the expression after the minus sign evaluates to 0, thereby offering no discount. Is the statement dis equal to 0 necessary? Yes. Since in C, a variable, if not specifically initiated, contains some unpredictable value, that is garbage value. So here is the flowchart for the problem statement seen before. You can have a look through the flowchart for a while and try to understand it by yourself. So this is how the flowchart works. The discount is initially put to 0. The input from the user is the quantity and the rate. If the quantity is greater than 1000, then the user gets a discount of 10%. And then the discount is put in the formula for totaling and the print is out. If the quantity is less than 1000, there is no discount and it directly goes into the formula of totaling and the discount is 0 and hence the total bill will be without any discount. We mentioned earlier that the general form of if statement is if with a condition which executes a statement. But truly speaking, the general form of if is as follows. If with an expression which executes a statement. Hence, the expression can be any valid expression, including a relational expression. We can even use arithmetic expressions in the if statement. For example, all the following if statements are valid. Note that in C, a non-zero value is considered to be true, whereas a 0 is considered to be false. In the first, if the expression evaluates to 5 and since 5 is non-zero, it is considered to be true. Hence, the printf gets executed. In the second if, 10 gets assigned to A, so the if is now reduced to if of A or if of 10. Since 10 is not 0, it is true, hence again printf goes to work. In the third if, minus 5 is a non-zero number, hence true, so again printf goes to work. So the issue is not whether the number is integer or float or whether it is positive or negative. Issue is whether it is 0 or non-zero, placed within a pair of parentheses as illustrated in the following examples. So next comes the problem statement. The current year and the year in which the employee joined the organization are entered through the keyboard. If the number of years for which the employee has served the organization is greater than 3, then a bonus of Rs 2,500 is given to the employee. If the years of service are not greater than 3, then the program should be nothing. And here is the given code. Observe that here, two statements to be executed on satisfaction of the condition have been enclosed within a pair of braces. If a pair of braces is not used, then the C compiler assumes that the programmer wants only the immediately next statement after if to be executed on the satisfaction of the condition. In other words, we can say that the default scope of the if statement in the immediately next statement after it. If-else statement. The if statement by itself will execute a single statement or a group of statements when the expression following if evaluates to true. It does nothing when the expression evaluates to false. Can we execute one group of statements if the expression evaluates to true and another group of statements if the expression evaluates to false? Of course. This is what is the purpose of the else statement that is demonstrated in the following example. In a company, an employee is paid as follows. If his basic salary is less than 1,500, then HRA is 10% of his basic salary and DA is 90% of basic salary. If his salary is either equal to or above 1,500, then HRA is Rs 500 and DA is 98% of basic salary. If the employee's salary is input through the keyboard, write a program to find his gross salary. So here is the code for this problem statement. Few points to note are the group of statements after if up to and not including the else is called an if block, and similarly the statements after the else form the else block. Had there been one statement to be executed in the if block and only one statement in the else block, we could have dropped the pair of braces, as with the if statement, the default scope of else is also the statement immediately after else. To override this default scope, a pair of braces as shown in the above example must be used. Next, going to nested if, it is perfectly alright if we write an entire if-else construct within either the body of the if statement or the body of an else statement. This is called nesting of ifs. This is shown in the following program. Note that the second if-else construct is nested in the first else statement. If the condition in the first if statement is false, then the condition in the second if statement is checked. If it is false as well, then the final else statement is executed. You can see in the program how each time if-else construct is nested within another if-else construct. It is also indented to add clarity to the program. It is better to inculcate this habit of indentation, otherwise you will end up writing programs which nobody can understand easily at a later date. In the above program, an if-else occurs within the else block of the first if statement. Similarly, in some other program, an if-else may occur in the if block as well. There is no limit on how deeply the ifs and the elses can be nested. I'm hoping that this gives you a clear idea about how if statement is used to give a condition to the computer for executing a particular set of instructions. With this, we come to the end of this class. Next class, we will learn about complex decision making, or you can say multiple if or if-else statements. Thank you.